Okay, so we're rolling. Let me shut the door here. So this first picture looks like this. And obviously, it's showing you in the next three, I think, 2 or 3 pictures, show the same type of thing with different ways to show the same type of molecule. So this is the molecule name, and we write it shorthand H2. And then you have the electron shell diagram, structural, and space-filling model. So can somebody tell me what you would what you would say about this particular picture?
Covalent bond.
Okay, covalent bond. So tell me what a covalent bond is.
It's when 2 molecules share the same molecule.
Okay, and so what about this let you know that it's a covalent bond? What about this picture?
Because they were overlapping, it appeared that they were sharing the same 2 electrons.
Okay, so this one right here, all right? So that's exactly what's going on here. So these guys are sharing electrons. Hydrogen has 1 valence electron. It has this is its outer electron shell. This outer electron shell, this represents the nucleus, which has protons and in most atoms, neutrons. And this first shell, can somebody tell me how many electrons it holds? 2. And so 1 hydrogen has 1 electron. So this electron, let's say, is part of this hydrogen atom, and this electron right here is part of this hydrogen atom. And so they both need 1 electron to have their outer shell filled, and so they each share their 1 electron with the other, and therefore that sharing of a pair of electrons is called a covalent bond, okay? So that's exactly what that's showing you here, and it's making a molecule of hydrogen, H2. And so hydrogen can only make ever 1 bond because it only needs one electron, all right, to fill that shell. All right, so that's hydrogen. Now we have oxygen. So the oxygen, so it's the same kind of 4 pictures here. What is this showing you? Yep. I have to learn names yet. So I'm going to put my seating chart here so I can take a look. So Grayson. That's right. They're sharing 2 pairs of electrons. So here's 1 pair and this is another pair. So notice oxygen, different than hydrogen in that it has a different number of electrons. 1 atom does. And so, so it has the 2 in that first energy electron shell. And then it has, this oxygen has 1, 2, 3, 4. And one of these pairs belongs to that. And one of these pairs belongs to that. So oxygen has 6 in the second shell. The second shell can fit 8. So oxygen needs 2 more electrons. So since these are both the same atom, the same type of atom, they both need 2 electrons. So if they both share with each other 2 of their 6 electrons, then they both have 8 in their outer electron shell, and therefore every oxygen atom makes 2 bonds. In this case here, the bonds are between the same atom, but it could be that oxygen bonds with 2 different types of atoms as well. And so the structural formula is written like this. Whenever you see a line, that represents a shared pair of electrons. So that's the 2 shared pair of electrons there. Okay. And so this is what we call a double bond. What classification of bond is this? Meaning, is it an ionic bond? What type of bond is it? It is a covalent bond. So this is a double covalent bond. Covalent bond means that they're sharing electrons. All right, so that's what we have going on here. So the last picture with hydrogen was a single covalent bond. And so now we have a double covalent bond. All right, so now we have a compound. This is different. Compounds are made out of different types of elements or atoms. And so water is H2O, made out of hydrogen and oxygen. And so what do we have going on here? So it's a compound, and what does this picture show you? Yep, two single covalent bonds that the oxygen makes, one with hydrogen and the other with the other hydrogen atom. So again, showing you that oxygen can only make two bonds. Like the previous picture, those two bonds went to the other oxygen atom. Here they go to two different hydrogens, and we have our water molecule. Okay? So then this picture and this picture are related. All right, what is this picture of? This is a water molecule, okay? So this picture shows this part of this picture here, but adds, I keep going back and forth here, adds some information on here. So the difference between those are these guys here, these symbols, and these arrows here. But you have an idea of what's going on with this picture and what those symbols and arrows may be showing you that the other picture didn't. Go ahead, Grayson.
Does the electronegativity stronger on the oxygen atom? It pulls the electrons and the hydrogens closer to
That's correct. So the word electronegativity, does that sound familiar to people? I'm going to put this and try something. Shows the picture better. All right, so remember trends on the periodic table. I didn't give this to you, but do you remember this from chemistry? All right, and so increasing electronegativity, which means that the atoms that have higher electronegativity draw electrons closer to themselves. And so oxygen is a pretty electronegative atom compared to hydrogen. And so there's oxygen and then hydrogen over there. So therefore, what that means is when an oxygen atom bonds with a hydrogen atom, yes, they're sharing a pair of electrons here. So they still are sharing a pair of electrons. But what happens is the sharing is not equal because they don't have equal electronegativity. And so the oxygen is more electronegative than the hydrogen. So while they're sharing these two electrons, they're not shared equally, which means the electrons orbit around the oxygen more than they do the hydrogen. And so therefore electrons have a what kind of charge? Just remember electrons have a what kind of charge? Somebody want to use their hands? It's a negative charge. Protons have a positive charge. They're in the nucleus. And so what happens is if these electrons that, like this was originally the oxygen's electron and this was the hydrogen, if they're not being shared equally and they are orbiting around the oxygen more than the hydrogen, then the oxygen would have a slightly negative charge because of this right here when there's shared pair of electrons. Because of the oxygen's electronegativity compared to the hydrogen, which means that hydrogen had its one electron by itself before it bonds with oxygen, but that one electron now is being shared with oxygen, which is drawn closer to the oxygen than it is to the hydrogen, which means that now hydrogen is now more slightly positive than it was by itself. And so that's what this is the Greek symbol, the delta here, that they represent partial charges. And so in a water molecule, because oxygen is bonded to two hydrogen, the oxygen has a slightly negative charge and your two hydrogen atoms have a slightly positive charge. And so these arrows here are representing what then? What are the arrows? The electron's moving towards the oxygen, and so therefore that's what's giving that oxygen a negative charge. And so this bond between the oxygen and the hydrogen is a sharing bond, so it's a covalent bond. But it's different than the covalent bond between the two oxygen atoms. So this was a covalent bond, and this is a covalent bond, and water is also a covalent bond, but these have unequal sharing. When you have two oxygen atoms, is this going to be unequal or equal sharing, do you think? They're the two of the same element, right? Equal, because they're both going to have the same electronegativity. They're going to draw their electrons equally to each other, so they're going to be shared equally. Therefore, O2, this is the O2 that we breathe in the air. So O2 does not have a charge on it. There's no charge, okay, on that molecule there. Does anybody know the difference of what we call those covalent bonds, whether or not the electrons are being shared equally or being shared unequally? a nonpolar and polar covalent bonds. Water, what does that represent? Polar or nonpolar? Polar. So polar is whenever you have unequal sharing and the result is a partial charges on your molecule. Versus like O2, this covalent bond would be an example of a non-polar covalent bond, meaning that they're shared equally and therefore there are no partial charges. So that's important to understand. All right, so looking at this picture here, what is this picture showing? All right, the ionic bonding of sodium and chloride here. So sodium and chloride, the chlorine atom makes sodium chloride here, and so we have a compound here made out of two different ions. An ion, if you recall, is an atom with a charge. And how did it get a charge? It either gained or lost what? Electrons. Okay, so that's what this picture is showing you here. So that's the difference between ionic and covalent bonds. Covalent, they're sharing electrons. Ionic bond is kind of the transfer there of electrons, where the chlorine atom has an additional electron and the sodium atom is missing one of its original electrons. So sodium has a slightly positive charge because that electron went to the chlorine atom, and chlorine has a slightly negative charge, and so opposites attract, so you get sodium chloride, which is our table salt. And so, so that's your ionic bond. All right, let's look at this picture. So this picture has water and ammonia, it says here, so water H2O, ammonia NH3. First of all, what do we know about ammonia based upon this picture? Okay, absolutely. So ammonia, these bonds here between the nitrogen and hydrogen would be what kind of bonds? Polar covalent. And so they're unequal sharing of electrons, and the nitrogen has that partial negative charge, just like the oxygen atom here in water. So, so we have these two polar molecules. We call these polar molecules because the bonds between the atoms are polar, and therefore they have partial charges. So both of these are polar molecules. What in the world is this little dot, 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 dot thing? Do you have an idea of what that is? This may be new. I'm not sure if in chemistry they got to this.
Is that bonding or a force of attraction?
It is bonding or a force of attraction, and the force of attraction would be due to what, do you think? Both being polar. So notice here about the two molecules, what part of the water molecule is attracted to what part of the ammonia molecule? The positive hydrogen to the negative nitrogen, right? And what do we know about opposite charges? They attract. All right, so therefore these two molecules, because of their polar nature, are attracted to one another due to the opposite charges. And we call this a hydrogen bond. You guys heard of this? Okay. Hydrogen bonds. And our textbook and hydrogen bonds are generally always written as these little dot, dot, dots. All right, so that's a common way to write and show the location of a hydrogen bond. And so, so water molecules can be attracted to any other molecule with a charge. So, or any atom with a charge as well. And so because of its polar nature. And if we had another ammonia, here, if we had another, I'm not going to draw it in, but if I brought in another ammonia molecule here, what part of the ammonia molecule would be attracted to the oxygen part of water? What do you think, Jacob? Want me to repeat the question?
Yes.
So if I were to bring in another ammonia molecule into this picture, what part of the ammonia molecule would be attracted to the oxygen part of water? Electrons of what atom? So if I were to bring another one of these, all right, or I bring another one here, what part of this molecule would be attracted to the oxygen part of this? Yeah, one of these hydrogens, right? The positive charge, the opposite charge. Okay, so water molecules can form many hydrogen bonds, multiple hydrogen bonds with different molecules. And this shows you a different molecule, ammonia. Can water hydrogen bond with other water molecules? Do you think? Absolutely, because other water molecules also have those partial charges. So that's our hydrogen bond. That's going to be really important in the next few chapters. Okay, so that's my quick little review here of chemistry and some bonding and so on. But what I'd like you to do is for this part here, I want you to make kind of like a concept map with these words to kind of show the relationship. The key here is making a visual representation to show the relationship. The key there is the relationship part. So, so I want you to look at these words. There are two words that we haven't yet talked about. It's intermolecular and intramolecular. So I didn't give you this, but I put the definitions up here. Intramolecular bonds are bonds that hold atoms together to make a molecule. And intermolecular bonds are bonds that hold molecules to other molecules. I'm going to jot that down next to it so you remember that. So, looking at those words, I want you to look at, kind of a starting point would be to look at what is the most general term that all the others would be included with. And then what I'd like you to do is kind of break it down to show the relationship between that word and all the other words. So you're kind of can use the words. You can start out with one word and put a box around it, and then draw lines to say, okay, that one can be broken down into what things, and so on and so forth. So you're going to make lines to show a visual representation of how these words kind of all fit together. And so, just like before, you can work with somebody else.
Excuse interruption. This time, Clarkston Junior High School students that take a shuttle back to the junior high only after their second hour should be dismissed. Again,
I don't
students
think
take a
they're
shuttle
gonna
to
do
junior
that
high
today.
only after their second hour class should be
The
dismissed.
junior high are
Thank you.
having wolf time stuff this week, and so they have to get back at a different time than normal for that. So I think it's special for this week, so it won't be forever.
I might do it on like a couple days next week, once it's all put
Remember, broadest word and then breaking it down to more specific. Okay, so everybody should have the most broadest word is what? Bonds, all right? So then your thought process would be, okay, are there different major categories of bonds? So what's the most next, I take bonds, what are the next more general categories? And then keep on breaking it down. Okay, so I'm going to call on somebody to come up here and share your screen. Ethan, you're up. I'm going to have you bring it up. I'm going to have you actually come up here, right? Come on down. You don't have to wear this, but I'm just going to sort of.
So I just make it on the board?
Yep.
Yeah. No, it's fine.
Oh, thank you.
Well,
All right, so let's look at this and see, looking at the relationships there. So we talked that the most general is bonds. So he has two lines coming off from the bonds, one for intra and one for intermolecular bonds. Are these two types of bonds? Yes, absolutely. So that's appropriate. So then let's look here, intramolecular bonds. Bonds that hold atoms together to make a molecule. So he put that there are two types on this list here of intermolecular bonds: covalent bonds and ionic bonds. Are covalent bonds and ionic bonds both bonds that hold atoms together to make a molecule? Absolutely. So we talked about the sodium chloride. That would be the bond to hold sodium chloride together as ionic, and then water and oxygen and so on was but for covalent. And then he has two lines coming from covalent bonds, polar and nonpolar covalent bonds. Those are two categories of covalent bonds. Polar meaning what's true about the sharing of electrons? Unequal sharing. Nonpolar then would be equal sharing. See what I'm doing here? I ask you a lot of questions and so on. This should be a way for you to self-assess yourself. If you are sitting there and you don't know the answers to the questions that I'm asking, that's your cue that you need to spend a little bit of time reviewing this material, okay? And so So self-assess yourself there. And then the intermolecular bonds, an example of that he's got is hydrogen bonds. Intermolecular bonds, remember, were bonds between molecules. So that would be like this. So hydrogen bonds is an intermolecular bond because you have, in this case here, this hydrogen bond between one molecule ammonia and another molecule water. They're two separate molecules that are attracted to each other just because of the charges that they have. So this bond is not talking about them sharing or transferring electrons. It's just that due to the construction of this molecule and this molecule, they have charges, and charges naturally attract. And therefore, we get this attraction between two different molecules versus this molecule, the atoms that make up this molecule are one of these kinds of bonds, which in this case here is a polar covalent bond, giving them different charges. And so that's the difference there between hydrogen and covalent and ionic bonds. I wanted to make sure it hit home with that because that's always every year that's a big source of confusion about hydrogen bonds versus covalent and ionic bonds. People want to clump them all together in the same category, and they're not really. They're two different types of bonds. And it's the hydrogen bonds that are really, really important for water. And water's being able to hydrogen bond to each other gives water all those properties that you wrote about in last night's homework, which makes water a very special molecule for living things. And so that's what we're going to look at next is water. And tomorrow we're going to do actually an activity where you're going to see look at different properties of water in action and so on. And then we're running out of time here, so I think I'll wait and do the notes. I was going to do just the beginning of the notes, so I can do that tomorrow as the first thing. Because I want to make sure we have enough time for you to come up with your cell phones, because that's a new thing. So to kind of be systematic about it, so it's not like a mad dash, we'll just do it by rows. So that row, come up and get your cell phones, and then we'll just go down the rows, so therefore. And I want to make sure before you leave every day that everybody has their cell phone. All right, so because if somebody doesn't have their cell phone, then nobody leaves. All the police officers. Nobody's going to do it on my watch.
We don't have to do this for one time.
No, that's going to be things that we're going to do in class.
Okay, all right, so we're good.
All right, next row, come on down.